Okay, continuing on with the straight line. So this is N5 section 6, part 3. So let's look at finding the gradient and the y-intercept of straight lines which need to be rearranged. So a typical example of that might be 3x plus 5y plus 2 is equal to 0. Now, what I need to try and do with this question is write the equation of the straight line so that it says y equals mx plus c. If the question asks me for the gradient of the y-intercept, or the point at which you cross the y-axis, I'm able to do that. So let's say this question asked me to find the gradient in the y-intercept. So I need to rearrange the formula to y equals mx plus c. So in essence, it's changing the subject of the formula. So keep 5y across on this side just now, but move your 3x and your 2x over to the other side and change their sign. So that would be minus 3x minus 2. Now be careful that you don't stop at that point. You're only in the form y equals mx plus c when it starts with y equals. So divide through by 5, and that's minus 3/5 x minus 2/5. So clearly the gradient of that line is minus 3/5, and the y-intercept is minus 2/5. Okay, another example, 11. 3x equals 5y minus 2. Well, to get going, small step, I would swap sides. 5y minus 2 equals 3x. 5y equals 3x plus 2. Now let's say the question just worded it slightly different this time. Instead of saying it's looking for the gradient and the y-intercept, let's say it looked for the gradient and the point at which it crosses the y-axis. Now crucially, if it's looking for a point, then you must state the x and the y coordinate. So this time we're looking for the gradient and the point at which we cross the y-axis. So divide through by 5, and that's 3/5 x plus 2/5. So this time the gradient is 3/5, the y-intercept is 2/5. But if I'm asked for the point, then I need to write it as 0, 2/5. Okay, question 12. This time, from a bunch of diagrams, we're going to identify which diagram could represent the information given in the question. Okay, so let's say the question was worded a bit like this. The gradient of a straight line is greater than 0. Its y-intercept is less than 0. The equation of the line is y equals mx plus c. Now the question might say, which of these could represent the equation of the straight line? So what we know is that the straight line has got a gradient which is greater than 0. That means it's sloping upwards from left to right. C, the y-intercept, is less than 0 below the x-axis. Now if the gradient is positive, that then rules out B and C. So it can only be A or C because those are the only lines which clearly have a positive gradient. Now what we also know is that the y-intercept is less than 0. Now if you look at A, the y-intercept is clearly above 0. The y-intercept here is definitely less than 0, so the gradient is greater than 0. The y-intercept is less than 0. That means the only one that it could be is option D. Okay, within this section there's also content called functional notation. We're going to have a look at that. Okay, so f of x equals 4 plus 3x. The question is looking for f of minus 2. These are straight substitution questions. Okay, so whatever you see in the bracket, that subs in for x. So we're going to make x equal to minus 2. So whenever I see x, substitute, make a swap, substitute in minus 2. So 4 plus 3x becomes 4 plus 3 lots of minus 2. That's 4 minus 6, and that is minus 2. Okay, next one. F of x equals x minus 9, and we're going to find f of minus 1. So where I see x, I make a straight swap, straight substitution, replace it with minus 1. So x minus 9 becomes minus 1 minus 9, and that's minus 10. Okay, example 15. F of x equals 8x plus 1. We're going to find f of 2 plus f of minus 3. So it's 2 substitutions and add them together. So f of 2, that's 8 lots of 2 plus 1, which is 16 plus 1, that's 17. F of minus 3 is 8 lots of minus 3 plus 1, that's minus 24, plus 1, and that is minus 23. Add them both together, and that will be 17 plus minus 23, 17 minus 23, and that's minus 6. Example 16. F of x equals x squared minus 6. Find f of minus 2. So where I see x, replace it with minus 2, so it's minus 2 squared minus 6. Remember to put a bracket around that when you're squaring it, and be careful with the negative. Minus 2 squared, so if you square something, you multiply it by itself. Minus 2 times minus 2 is plus 4, so it's 4 minus 6, minus 2. Example 17. F of x equals 7 minus x squared. We're going to find f of minus 5. Where I see x, replace it with minus 5. So 7 minus minus 5 squared. That's 7 minus, well, minus 5 squared is 25. So that's 7 minus 25 minus 18. Next one, we've got f of x equals 8x plus 1. The question, a bit different this time. F of a equals 17, find a. Now what a lot of folk will do at that point, and it's not correct, is to sub in 17. Now look closely at what we've done before. You subbed in the thing that was in the bracket. So if it was in the bracket was 2, you replaced x with 2. If it was 3, with 3. If it was minus 1, you replaced it with minus 1. Now what's inside the bracket now is a. So forget 17 for a minute. Where I see x, I'm going to replace it with a. Where I see x, I'm going to replace it with a. So 8x becomes aa, and that's 8a plus 1. Now just read the question carefully. F of a equals 17. F of a, which is equal to 8a plus 1, is also equal to 17. That's now a simple equation to solve. A is 16 and a is 2. Example 19. F of x equals 3x minus 5. F of a equals 10, and find a. So again, where I see x, replace it with a. Forget the 10 for a minute. So don't sub in 10, we sub in a. So where do you see x, replace it with a. Instead of 3x minus 5, it's 3a minus 5. Now we know f of a is equal to 10, and it's also equal to 3a minus 5. 3a minus 5 is equal to 10, 3a is equal to 15, a is equal to 5.